This is a PowerPoint about Dalton's atomic theory. So here's a few pictures of different ways people view atoms. Like if I were to say the word atoms, here's 3 pictures that may pop up into your head. So Dalton had 6 postulates on his atomic theory. The first one was he said that all matter is made up of tiny particles called atoms. He also said that they're indivisible particles, which we later learned he was not correct on that, but that they're indivisible particles that can't be created or destroyed in chemical reactions. The third and fourth postulate are pretty much saying the same thing, like all atoms of a given element are the same in mass and chemical properties, where if the atoms are different, they're going to have different masses and chemical properties. The fifth postulate says that atoms combine in ratios of small whole numbers to form compounds. And the last postulate of his theory says that relative numbers and kinds of atoms are constant in the given compound. And in these next few slides, I'll go through and explain what each of these postulates mean. So his first one states that all matter is made up of tiny particles called atoms, and this just means that you can continue to half the matter into smaller and smaller sections, and you're just going to get atoms. This is also how he was wrong about the indivisible part, but I'll explain that a little bit later. So here's the one where he said they're indivisible, which that was not correct, but he was wrong about them being indivisible because we can split atoms into smaller things. We can get protons, neutrons, and electrons, which we later learned he didn't know, so it's okay. But atoms they're pretty much like the fundamental units. But atoms can form together and they can make new units, but atoms can't be formed. And atoms that we already have, they can't be destroyed. So I've put some atoms here, or elements, and they can add together and they can form combined atoms, but element Q and element R, they can't form and make a new atom. Atoms can't be made or destroyed, but they can be combined or rearranged. So his third and fourth postulates say that all atoms of a given element are the same in mass and chemical properties. Likewise, if they're different elements, then they're going to be different in mass and chemical properties. So I've used element Q and element R again, and element Q, here's the same elements, and they're all the same size, so they're going to be the same mass, and they all have the same chemical properties. Here's element R. Element R is all the same size, so they're going to have the same mass, and they have the same chemical properties. But element Q, one of its elements, does not have the same mass or chemical properties as one of element R's. And that was his third and fourth postulate. So this is the fifth postulate, and it states that atoms combine in ratios of small whole numbers to form compounds. So here I have this compound. There are 2 element Q's for every 1 element R. And 2 element Q's, 1 element R, those are both whole numbers. 2 and 1 are both whole numbers. So what he's saying is in a compound, you're never going to have like 1/2 of element Q to every 2/3 of element R. It's always going to be whole numbers. So his sixth postulate states that relative numbers and kinds of atoms are constant. So I've reused this picture from the last slide, and in compound S, since there's 2 element Q's to every 1 element R, that's going to be constant throughout the whole compound. There's never going to be 2 element R's for every 1 element Q. It's not going to change. It's always going to be 2 element Q's to 1 element R. And to pretty much sum it up, in a chemical reaction, atoms don't change. They're just rearranged, and they cannot be destroyed. And all matter is made up of atoms.